Finishing up our unit on parametric equations, we have to touch upon vectors. We have something called a position vector, and the position vector is x of t, y of t. Okay, the derivative of position, you know, is velocity. We have a velocity vector. The velocity vector is x prime of t, y prime of t. And one more time, the derivative of velocity is acceleration. So we have an acceleration vector, and that would be x double prime of t, y double prime of t. Okay, sort of things that you already know. Two more things, speed. We need to figure out the speed of a vector, and the speed is equal to the square root of dx dt squared plus dy dt squared. And the last thing that we need to know is distance traveled. And distance traveled is an integral from A to B, actually of speed. Square root of dx dt squared plus dy dt squared dt. Okay, these are the equations that will get us through the entire unit here on vectors. So let me give you a couple of examples. I'm going to give you a position vector and ask you several questions about it. Okay, so the position vector I'm going to give you is, let me just write position, and the position vector is 4 cosine of t, radical 2 sine of t. And I would like you to tell me what the velocity vector is and the acceleration vector is. Okay, so the velocity vector, we're just taking the derivative of that, and you'll get negative 4 sine of t, comma, rad 2 cos t. We're just taking derivatives, that's all we're doing. Acceleration vector is the derivative of your velocity vector. It's negative 4 cosine of t, negative rad 2 sine of t. Okay, the next thing I'm going to do is I'm going to ask you to evaluate the velocity vector and the acceleration vector both when time is equal to pi over 4. Okay, so your velocity vector at time is equal to pi over 4. We put a pi over 4 in terms of t, in place of t. We put a pi over 4 in place of t. You have negative 4 sine of pi over 4, and it's negative 2 rad 2. Put a pi over 4 in place of t here, and your value is 1. One more time, evaluate the acceleration vector at time is equal to 4. Substitute it here. We get negative 2 rad 2 again, and over here we get negative 1. Okay, I can ask you to do one more thing here. I can ask you, what is the speed at time is equal to 4? So you have in your notes, it's the square root of dx dt squared, but we have our number right here. So we have negative 2 rad 2 squared plus 1 squared. Works out nice, and you get the number 3. All right, there's one more type of question that I can ask you, and we'll work on it now. And let me give you an example. So let me tell you that dx dt is equal to the square root of 3t. The entire thing is under the radical sign. And dy dt is equal to 3 cosine of t squared over 2. These are calculator questions, so you should have your calculator out. I'm also going to tell you that at time is equal to 0, my particle is at position 1, 3. And that information is given to you, and my question is to find the position when time is equal to 4. position at time is equal to 4. Okay, we have to do it separately. We have to find out our new x coordinate. We have to find out our new y coordinate. So in order to get the x coordinate, you want to integrate from 0 to 4. I'm starting at 0 because I know when time is 0, I know what my position is. I'm stopping at 4 because I'm asking you about 4. We're going to integrate 3t dt. If you remember, when you integrate velocity, you get distance traveled. So this is something you can actually do without a calculator. I wouldn't. Use a calculator and you get 9.2376. And what this is telling you is from time is equal to 0 to time is equal to 4, our particle moved that many units to the right. I know it's to the right because I'm working with respect to my x-axis. To the right of where it started. It started at position 1. So you're going to add 1 to this and you'll get your new position for x. Okay, we have to do the same exact thing for y. We're going to integrate from 0 to 4 and we're integrating 3 cosine of t squared over 2 dt right in the calculator. And you get 3.3994. And that's telling you from time is equal to 0 to time is equal to 4, our particle moved that many units up. I'm saying up because it's my y-axis and that's a positive number. Up from where it started. It started at the number 3, so I'm going to add 3 to this, and I'm running out of board space here, and that would be my new position. My x value is 10.2376, and the coordinates for y would be 6.3994. Okay, if I ask you the distance traveled, how far did this particle move from time is equal to 0 to time is equal to 4, you're going to integrate from 0 to 4. The square, this squared, rad 3t squared, I'm just going to write it as 3t. And we want dy dt squared. I'm going to write 3 cosine of t squared over 2 squared dt. This absolutely goes right in the calculator. And the distance traveled from 0 to 4 is 13.1824. Okay, so you can click on the lesson Parametric Equations number 2. There are some notes there, very similar to what we just did, and then a few examples for you to try. And we're finished with parametric equations.